Okay, just been walking around and I want to remind everybody of something really, really important with your diagrams. Scale. Okay, really look at your diagram and see, have you reflected 300 meters and 500 meters appropriately with the length of the arrow? And did you draw an angle that represents 75 degrees north of east? That's only 15 degrees from vertical. It's like that, okay? Scale's important on this one. That's why we do this one as an example, okay? It's to illustrate the importance of your diagram will lie to you if you don't take scale into account, okay? I'll give you a couple more minutes and I'm gonna draw the picture. Okay, so watch up here, guys. So when I'm drawing this diagram, okay, I have a 300 meter long vector going due south, okay? My next line is 550 meters. It's almost twice the length of that arrow, agreed? Okay, and it's 75 degrees north of east. All right, so I'm gonna draw my reference line due east, and then I'm gonna go 75 degrees north of that. That's like that. And then I'm gonna draw a line that is 550 meters long. That might not even be quite right, okay? Could maybe be a little longer than that even, okay? So this would be the x component of this line. This would be 550 meters, okay? 75 degree angle. That would be the y component. That would mean that this line right here would be my resultant. Okay, so this will be the overall displacement. This will be x, this will be y. Okay? When two vectors backtrack on each other is when scale matters the most. Okay, and these definitely do. All right, give you a few minutes to try the rest of it and then we'll solve it together. Okay, so once we have the diagram drawn and we've been careful about our scale, okay, we need to find all the x and y components. Finding the x and y components for the first 300 meter due south vector is really easy. What's its x component? How far east or west does that one go? Doesn't go east or west, it goes south. Okay, so its x component is 0, right? So I can basically say the x component of that black vector is 0 meters, and the y component of that vector is 300 meters south. I don't have to do any trig for a straight vertical line. I can't. It doesn't make a triangle. Everybody all right with that? Just so you know, the one I put on the unit exam last semester looked just like this, except it was flipped to east and came back northwest. Okay, like it's basically the same level of difficulty as this one. All right, so for the red triangle now, I do have to do some trigonometry because I actually get a triangle with this one. If I want to find the x component, x in this triangle is adjacent to the 75 degree angle. Okay, so as a result, I'm going to use cosine to find out what x is. All right, so I'm going to go cos of 75 times the hypotenuse, because that's the side I know, 550. Okay, cos of 75 times 550. All right, so that side's going to be 142.35 meters. And I'm keeping all those decimals in my calculator. I'm just not drawing them or writing them all. Okay, and that one's directed east. The y component is opposite the 75 degree angle. So I'm going to go sine of 75 times 550. Okay, 531 meters, or 531, we'll say 0.26 meters. And that is north. Okay, this one goes north, that one goes east. All right, now that I've got those, can I find the x, how much east it goes and how much north it goes in total? I can, okay? Because now I know all of the parts of the trips. Okay, so if I'm looking now at my final triangle here, calculating blue x is actually really easy. I didn't go east or west here, so according to my diagram, red x and blue x should be the same. Okay? This is the only time I went east or west was when I was going east with the 550 meter long vector. Okay? So x is simply going to be 142.35 meters east. Okay? That's how much we went east in total. Okay? But we're 142. All right, now the y, that one's going to require a little bit more because first I went 300 and then I went back 531.26 meters. Okay, everybody all right with that idea? Okay, I went south 300 and then I went north 531. All right, so if I want to get the total here, okay, I would simply go, all right, I went 531 north and 300 south. There's going to be my total amount north, okay, that I went 231.26. Okay, now what do I do? I know how far over and how far up I went in total. Can I find the magnitude of the total displacement somehow? How would I do it? I know that side's 142. I know this side's 231. How will I find D? Exactly. A squared plus B squared equals C squared. Pythagorean theorem. All right, so if I want to find what my displacement's magnitude is, and I keep accentuating, I'm only finding the magnitude here, okay? 231 squared plus 142 squared. And I'm going to keep all the decimals in there. I'm just being lazy about what I write. All right, so square root of that number squared plus that number squared. Okay, gives me 271.55, but I only have 3 significant digits, so 272. Actually, I only have 2 significant digits. Okay, this angle is down to 2 here. So we're looking at 2.7 times 10 to the 2 meters. That's the magnitude of my displacement. Now I need to find which way my displacement points. It is, after all, a vector quantity. Okay. Can I use trigonometry to get that number? Okay. I have all 3 sides, so at this point I can use any trig function I want. Okay. Theta is the inverse tan of the opposite side, 231, divided by the adjacent side. Oh, sorry, I did that backwards. The opposite side. The opposite side is 142. 231. Okay, so I'm getting 32 degrees there, okay, and that's all right. 32 degrees east of north. Okay, so my final answer would be 2.7 times 10 to the 2 meters at 32 degrees east of north, or at 58 degrees north of east. Either one of those is the same direction. Okay, they're the complementary angles to each other. Okay, is that ringing a bell from Friday? Okay, we actually did a harder one than that on Friday. So, steps are always the same. First I drew the picture. Then I identified all the x's and all the y's. I knew that I didn't have an x for the black one. I did have a y, and it was 300. Then I calculated the ones that involved trigonometry for the red vector, right? Then I combined the x's to get blue x. I combined the y's to get blue y. I did Pythagorean theorem to get the resultant. And then I did trigonometry to get the angle. It's always the same steps. Once you've got those steps down, you really can't go wrong. Okay? Questions on that one? Okay, I'm not kidding you when I say the one I put on the unit exam was exactly the same level of difficulty as this. Literally, I flipped it so that it went east and then north of west. Okay, it went backwards. It's exactly the same type of problem. Okay. Now, importance of scale. Can we agree that scale is important? Okay. Like in walking around and looking at people's initial diagrams, okay, I saw a lot of this and then like that. Okay, and I saw a few people that are like, oh, sweet, you're not that lucky. You're never going to be that lucky on a question where that's going to work out to be perfectly a right angle triangle for you, okay, because it would make your life way too easy, so you're not that lucky. Okay, and I had a few where, you know, they drew it a little bit short, or they drew it off this way. Okay, like we really, and that's just experience. I'm not trying to make fun of you. Okay, that comes with experience. You got to make sure you're representing that scale as best you can, because otherwise, if you do all of that same math we did with that diagram, you're going to say, all right, my resultant looks like this, and when you're done, you're going to go, wait a minute, my resultant's supposed to be this long and it's supposed to be pointed this way. Mine doesn't look that way. I must have screwed up the math. Nope, you screwed up the diagram. Okay, so we got to be super, super careful with our diagrams. Okay, let's try none of those. Okay. Try this one, and then we're going to take a little bit of a break after this one. This one, they're both angled, okay? So it's harder than what I would ask you to do on a test, but it's good for practice, okay? On this one here, do we have backtracking happening? Okay, it starts out south of east, goes back north of west, okay? Or sorry, goes north of west and then goes south of east. That backtracks on each other. Is scale going to be important? Yeah, really important here to get the diagram right. Okay, I'll give you a few minutes to get the diagram, then I'll draw it. All right, so we'll start out with the first vector, 950 meters at 30 degrees north of west. Okay, so here's my reference line that goes due west, okay, and 30 degrees. Probably something like that. All right, so I've drawn the first vector. I've got its x and y components identified. I haven't calculated them yet, but they're on there. Okay. Next thing I need to do is I need to draw my second vector, which is 385 meters at 45 degrees south of east. So I'm going to draw myself a reference line that's due east, but it's going to be less than half as long. Sorry, my overall line is going to be less than half as long as the first one. Would you agree? Okay. Now, if this angle was 30, so is this angle. So 45 is going to be a little deeper than that. Yes? Okay, it's got, well, I didn't do a very good job. That's probably closer to 60. Let's try slightly. Okay, so 385 meters. That might be a little bit short, and I could probably have made it a little bit longer, but at least my diagram's not going to lie to me too badly. Okay, this will be x, this will be y. Okay, and then my overall resultant will go from start to finish. Like so, and it's triangle can look like that, or you can draw it the other way. You can draw it this way and up. Either way will work. Now, does this diagram get a little messy? I mean, everything overlaps everything else. Sometimes that happens. Sometimes they do get very busy looking. Okay? That's why I use different colors. Okay? You can use pencil crayon if you want, or you can just, write 1, R, like X1, X2, Y1, Y2 to kind of tell the difference. That's totally up to you. Okay? That's what our overall diagram should look like. Okay? But scale was certainly important on that one. Okay? I'll give you a few more minutes to get ahead of me again. So obviously these take a while, okay? Especially if you're kind of, rusty on your trig or anything like that, and that's okay. Like, there's no shame in one of these taking quite a bit of time. So first off, we've already drawn the diagram. We've identified the x's and y's, but we haven't calculated them yet. So that's the next step. So we'll start with our first vector, which was the green one, 950 meters, 30 degrees north of west. So x is adjacent to that 30-degree angle. Right, so we're going to go cos of 30 times 950, and that will get us our green x. Right, so cos of 30 times 950, right, gives us that side is 822.72 meters west. Okay, everyone with me so far? Okay, if you get lost, put your hand up and let me know, and I'll slow down. Okay, green y is obviously opposite the 30-degree angle. Okay, so for that one, we're going to go sine of 30, okay, times 950, which should give us 475 meters north. I did not do trig in my head. Okay, the sine of 30 is 0.5. So I use 30 degrees as often as possible to feel like I know how to do trig in my head, but I don't. Okay. All right. Then we've got to do the purple triangle. Okay, so the purple triangle here, x is again the adjacent side to that 45-degree angle. But what's the nice thing about a 45-degree angle? What are x and y going to be? The same number. Sometimes I'm generous that way. It doesn't seem like it at the time, but sometimes I'm generous. Okay, and I give you an angle where you do less work. Okay, if you put in cos of 45 and sine of 45, you won't the next time. Okay, if you do it this time, that's okay, but you probably won't do it the next time. Okay, and you'll save yourself some time. All right, so x is the cos of 45. Okay, times, what was it, 385. Okay, so this side, yeah, we do actually have to punch in what the cos of 45 is. Okay, we just don't have to punch in what the sine of 45 is. All right, so cos of 45 times 385. All right, it's 272.24. Okay, and that's meters, and it is east. Okay, and then y, since it's the sine of 45, it's going to be the same number times 385, same number, is going to give us 272.24 meters, but now it's south. Okay, now I've got all the x's and all the y's. Okay, so now I can find my overall displacement, the red triangle, okay? So to get red x, okay, red is going to be the vector sum of purple x and green x, which go in opposite directions. So I'm going to have the 822.72, okay, plus negative, because x is east, okay, purple x, sorry, is east, 272.24. Okay, so we'll have our 822, okay, minus the 272. All right, so my overall east-west part of this is 550.49. Meters west. Okay, how did I know it was west? Two ways. I had a positive number and I made west positive. And my diagram tells me it's west. Okay, because my final arrow points north of west. Okay, so there's two ways to tell. All right, then I've got to get red y. Okay, red y is going to be the vector sum of green y, which is north, and purple y, which is south. Right, so green y is 475 meters, okay, plus negative 272.24. Right, so that's going to make red y. Okay, 202.76. Meters, and that is going to be north. Okay, everybody all right with that? Have I done anything different on this question than any of the other ones? Nothing. Exactly the same steps on all of these. All right? So now, if I want to find my overall displacement, which is the hypotenuse of that red triangle, I'm going to use Pythagorean theorem. All right, so that's going to be the 550 squared, but with all the decimals, plus 202 squared with all the decimals. All right, so that number squared plus 550 squared. Okay, so my overall resultant is 586.64 meters. Okay, the other thing I need about that is I need the angle. Now the way I drew this triangle, okay, I'm looking for this one. If you drew the triangle the other way, you're looking for that one, and that's fine. There's actually two correct answers for a question like this. Okay, so theta equals tan to the minus 1 of the opposite side, which for me is the 550, divided by the adjacent side, the 202. If you drew the triangle the other way, those are flipped. Okay, so I'm getting an angle here of 69.78 degrees. And for me, that is west of north. If you drew the triangle the other way, then you got 12 degrees north of west. Okay? Or sorry, not 12 degrees, sorry, you got 20 degrees, 20.22 degrees or something like that. Okay? Everyone all right with that? Yes? Okay. What does the question ask for?
Velocity.
It asked for velocity. What did I just calculate?
Displacement.
I calculated displacement. They gave me one other piece of information. The whole trip takes 540 seconds. How do I calculate velocity?
Total displacement over total time.
Total displacement over total time. So in this last kind of silly step, okay, I take that 586, I divide it by 540 meters, or 540 seconds, and I will get my overall velocity with this same vector. Okay. How many significant digits can my answer have after all of that?
2.
2. Okay? The 30 degrees has 2 significant digits, and angles are measured values. So they contribute to your significant digits. Okay? So we are going to have here, okay, as our final answer, I think it was 1.1, right? Yeah, it is going to round up. Okay, so our final answer is going to be that the velocity equals 1.1 meters per second at 70 degrees west of north, or at 20 degrees north of On a test, obviously, both of those numbers would be correct because they are the same direction, referenced from different compass directions. Okay? Questions on that one? Okay, take a deep breath, because that's a big question. Okay? Question like that takes a long time to do, okay, till we get good at it, till we know the steps off by heart. We're faster at typing in all that trigonometry into our calculator. It takes a while to do a vector addition question when you're first starting out. All right, I'm gonna give you about a 4-minute break here right now. Then we're gonna talk about how the week is gonna go, what I've got planned for the week, and then we'll try another question like this. We don't get many of these done in a class when we first start out, okay, so it kind of takes a while to get rolling. Well, let's talk about how the week is gonna go here. So today, we're gonna work on this, obviously. Tomorrow, you'll have a quiz, it'll be on this. Then we'll work some more on this. Wednesday and Thursday, we're actually gonna do a group activity using maps. So you guys can choose your groups, you're gonna plan a route through the mountains, do some simple vector calculating, v equals d over t stuff. It's pretty straightforward, it's practically gimme marks. That'll be Wednesday, Thursday. Friday, we'll work a little bit more on this. Then you get a week to forget it all. I'll teach it again on the Monday when we come back. That's more than likely what's gonna happen. So that's the plan for the week. Like I say, the map activity is just, it's a bit different. You do some vector component stuff, so it does still involve doing some of this, but it's not just sitting around doing the same kind of questions over and over again. And it is coming in for marks, so it will count towards your final grade. Like I say, it's fairly easy marks, so it's helpful in that way. And then we will also remember that your position versus time labs are due on Thursday. I've only had a couple of people come in to have me look them over. So if you would like to take advantage of the fact that I will do that for you, bring them in tomorrow lunch, tomorrow, I'll probably do tomorrow after school. I can't do today after school because I have to jet. But, you know, come and see me and I will have a look over them and give you some feedback on those if you want. If you don't want to, that's fine too. So that's the plan for the week. Okay, please make sure you have those position versus time graph labs done on time. Submitted through Google Classroom, 8:30 a.m. on Thursday. Okay. All right. Well, let's see here. What do we have? No, that's too easy. I would like you. Oh no, that's still finding X and Y. Okay, I would like you guys to try. Let's say C. No, sorry, D. Sorry, very wrong. Sorry. I'd like you to try D. All right, D is another one that's basically just like what I will put on your unit exam. Your unit exam always has one that's either horizontal or vertical, and one that's angled that usually backtracks on the first slide. And that is exactly what's going on in D. So I'll give you a couple minutes and I'll draw the diagram. So guys, I'll put the diagram up here for you. So we got 12 meters south and east and north. So there's our 12 meters south vector. And then we have 15 meters at 55 degrees east of north. So that's a longer line, but because it's 55 degrees, it's more than halfway down. Might get a little bit longer than that. So that's what your diagram should look like. Okay. this is another one where scale is so important. So many people draw that 15-meter line past, like north of where they started, okay? Forgetting that 55 degrees is more than halfway down from vertical. A 15-meter line is never gonna get past where it started at an angle like that. So scale is really, really important on ones like that. All right, guys, I'm gonna quickly run through the calculations here because at the end, I wanna show you another way to draw these in case you're struggling with the diagrams. There's another way to diagram this that is sometimes a little bit easier, and scale doesn't matter as much in that method, okay? So for red X and red Y, because the 12 is due south, there's no X component. It doesn't go east or west, so that's 0. Its Y component is simply 12 meters south. That's it. For the green triangle, in the green triangle, we do have trigonometry to do. Looking at the X component, it is opposite the 55-degree angle. So that'll be the sine of 55 times 15 meters. All right, so we're looking at 12.29 meters, and that is east. And then for Y, it's adjacent, so we would go cos of 55 times 15 meters. Or we're looking at 8.60 for that one. And that is north. So now that we've got those, now we can look at solving for the blue triangle here. So for blue X, well, blue X and green X clearly in that diagram are equal. They're the same line, right? They go right over top of each other. So, and that's simply because the red vector doesn't go east or west. The only time I go east or west is in the green triangle. So blue X and green X are equal, and that makes them 12.29 meters east. For Y, we actually do have to do a little bit of calculating. We go 12 meters south, and then we go back 8.60 meters north. So we'll have to go 12 minus 8.6 with all the decimals obviously in the calculator here. So 12 minus 8.60, and that is going to give us 3.40. We're going to save it. We'll keep all the stuff in our calculator. 3.40 meters south. Okay, so now I know what blue Y and blue X are. Now I can calculate my overall displacement magnitude. So that'll simply be 12.29 squared plus the 3.40 squared. Okay, so that number squared plus that number squared, square rooted. We're looking at 12.75 meters for D. We also need the angle, so we're going to use X and Y here in a tan calculation. So tan to the minus 1 of the opposite side, the way I drew this triangle, that's X, the 12.29 side, divided by 3.4 with all the decimals in it when I do the calculator. So we're looking there at 74.5 or 75 degrees, because we only have two significant figures here. 75 degrees. For me, that is east of south. All right, so my final answer is going to be 13 meters, because I only have two significant digits, 13 meters at 75 degrees east of south. Now, something you may or may not have noticed, because if you're struggling with drawing the pictures, you can actually use what we call the separate triangle method. which involves basically disobeying the first rule of vector addition, drawing tail to head. I don't have to necessarily draw tail to head. I could have got this, I could have got this blue triangle here. Oh, that's not what I want either. I could have got this blue triangle without drawing the red and the green together. I could have drawn the green separately. Sure wish these would all go together. Okay, would I have done all the same calculations here if I didn't draw the green triangle on the red line? So would I have still got this triangle at the end? Here's the one drawback of using a separate triangle method. You don't see that triangle until you're done. Okay? The nice thing about drawing tail to head is you see that triangle before you've calculated anything that contributes to it. With the separate triangle method, you've got to calculate it all before you see the triangle. But some people like that because they just get overwhelmed with how busy one of those tail to head diagrams can get. So tomorrow, after your quiz, the first one we'll do will be a separate triangle question. You can see if you like it. If you like it, you can do it that way. Okay? So practice quiz is going to post here shortly. Make sure you try it tonight. There's a solutions video as well. And then tomorrow, that's what's up.